Good evening, my dear JEE warriors. So, welcome to the next session of your JEE Advanced series. And here we are discussing the PYQs of electromagnetism. And these are some hand-picked PYQs, which means they are going to involve some really amazing concepts. And each question might even take some decent amount of time to justify and come to the conclusion or the answer. Okay, so get ready, my dear warriors, because this will definitely open up new ways or new I would say concepts which otherwise you might not have understood or forgotten or probably just left it for J Advance. So let's get to it. The top best PYQs from electromagnetism. I hope you guys are able to see me and hear me loud and clear. Let me know, guys, quickly. Hi, H Perfect. Hi, Revti. Hi, Radha. Good evening, my dear students. So let's begin with the class. And those of you who do not know me, my name is Shreyas, your Captain Shreyas, and I have been training kids for more than 13 years now, and I'm extremely proud that many of my kids are doing really well wherever they are. And this year, of course, just with couple of weeks in hand, I want to give my 100% because you also want to give your 100% for getting a seat in IIT. And when we talk about IIT, it's never a joke, it's never a simple thing. It's always lot of hard work, patience, focus, and going deeper and deeper into the subject. So let's get it through, guys. Quickly smash that like button and also subscribe to the Vedantu JEE English channel. All right. Hi, Bhargavan. Hi, Gokul. Good evening, my dear students. So let's begin with the class. Okay, perfect. And by the way, those of you uh, have your younger brothers or some colleagues or friends or batchmates, juniors, whatever, and if they are interested for the Vedantu's offline programs, then let me tell you the admissions are open for foundation classes, JEE classes, and even NEET classes. You can visit any of your nearest Vedantu learning center where you get personalized attention, smart clickers, and so many other things. And you are getting up to 40% scholarship on all the courses which are about to start in the next couple of days or weeks. So make sure you are visiting any of the centers which are closest to you, but please pass it on to your friends or maybe your juniors who might be interested in it. Okay, so that's one important piece of information. The link for any of the offline centers is also there in the description box below. Okay, even the dropper batches are there for JEE and NEET in case you want to appear for JEE next year. Right. So let's begin with the multiple correct questions. Read the question carefully. Hi, Siva Prasad. Yep. I'm doing advanced PYQs and rank accelerator. Yes, definitely. It's a good strategy. 59.8 percentile. I doubt rather. I think the cutoff will be much. Oh, for ST. Yes, definitely. I think you might be able to qualify for J Advance. Yes, definitely. Okay, so let's begin, guys. Read this question. There is a source and it is connected to some resistance and two inductors L1 and L2. Okay, and there is a switch also. Now, what happens is there is no mutual inductance, so ignore mutual, only consider the self-inductance property. The switch is closed at time 0, and then the currents will start flowing in the circuit. Which of them are true? After quite some time, what is the current in L1? What is the current in L2? What is the ratio of the currents? And at t is equal to 0, the current through the resistor R is how much at t is equal to 0? Okay, so I think I have only the diagram ready, so that will help me solve it in a much better way. Okay, first things first, tell me clearly, both these inductors, don't you see the voltage will be the same? Both these inductors, can't you see that the potential difference across them, delta V, is going to be same for L1 and L2? That means L1 is parallel to the inductor L2. Voltages are same. The inductors are definitely going to be parallel. Everybody fine till this point? Okay. Now let's think what will happen next. If there is some current coming after the switch is closed like this, that current will go here. Some of the current will enter here. Some of the remaining current will go here. This current I can call it I1. This current I can call it I2. Okay, somehow I might have to relate currents with inductance somehow. Let's think about it. But before going ahead, I know one thing. Since the voltages are same and the inductors are in parallel, the voltage across an inductor is given by L di by dt. Yep. So can I not say, therefore, L times di by dt in the first inductor is L times di by dt in the second inductor because the voltages are same. Yep. Is that clearly understood? Dt cancels. So I'm left with L1 di1 is equal to L2 di2. Okay, I have an idea now. How about maybe integrating this with this, starting from 0 to I1, this is from 0 to I2. So when I integrate, I will definitely get L1 I1 is equal to L2 I2. Okay, perfect. So therefore, I1 divided by I2 is nothing but L2 divided by L1. And this is true at any instant. This is true at any instant, basically. We did not take any specific time. Anyways, the time got cancelled. So the ratio of the currents is of specific value. I think such an option is there. The ratio of the currents through the inductors is fixed at all the times, at any instant. So definitely option C is correct. Is this fine? Remember, this is a multiple correct kind of question. That means more than one options may be correct. So we have to go through other things also. Before going to the other things, I can see one more thing. The current through the resistor initially is V by R. What do you think about this, guys? Current through the resistor initially is V by R. I'll tell you one thing. Keep this in mind. Very important. When an inductor is just connected into the circuit, that means the switch is just closed. When the inductor is just connected in the circuit by closing the switch, versus it's been a long time after closing the switch. Basically, a steady state. Basically, it is a steady state after closing it for a long time. The behavior is as follows. The behavior is as follows. In the first case, when it is just closed, it will behave like an open circuit. Whereas when it is in a steady state, it will just behave like a pure conductor, like a simple wire, which is basically a closed circuit. That's it. It behaves like a wire. There is no voltage difference at all. Now, if you consider t is equal to 0, when you consider the time t is equal to 0, when you are basically just closing, when you are basically just closing that particular switch, both these things will behave like an open circuit, will behave like an open circuit. Isn't it true, guys? It will behave like an open circuit. So if it behaves like an open circuit, that means what? There will be no current only in the circuit. So the current in this particular circuit will be 0 at t is equal to 0. So there will be no current. And as per this option, the current through the resistor is V by R. Obviously, this is 100% a wrong statement. This is also very, very clear. Can you see that? Yes? Okay, maybe some of you might have solved this PYQ, you might know the answer, Siva, but we are trying to get through each and every concept of this problem. Now comes the last part. How do I find the value of I1 and I2? Here comes the knowledge of Kirchhoff's current law. Yes, in current electricity, Kirchhoff's current law is there, where the total current is basically I1 plus I2. I1 plus I2. So maybe I can substitute I2 over here or I1 over here. Can you see from here what I can do? This particular current, because I think the options are also like this only. This particular current, I can write it as, let's say, I1, I put it as I2L2. I2L2 divided by L1. I2L2 divided by L1 is I1 plus your I2. So this will nothing but be I2 common. It will become L2 plus L1 upon L1. Okay, so that is basically I. But wait a minute. I know after closing it for a long time in the steady state, because they will just behave like wires. So after a long time, when it is closed, this circuit will just be one resistor and this wire. This is when time is infinity, and therefore this current which is flowing will be just V by R. This current will be just V by R. So instead of this I over here, I might as well put this as just V by R. Therefore, from this particular equation, I will get the value of I2, which is V by R, and then you have L1 on the top divided by L1 plus L2. Same way, similarly, by symmetry in relationship, similarly, I can say that I1 will be V by R instead of, see, when there is 2, there is 1. So when there is 1, there will be 2. So by symmetry of relationship, this will be L1 plus L2. You don't have to work it out again. It will obviously be this. So I think it might be matching. Yes, the current through the L2 will be L. I think they have made a mistake in the wordings. After a long time, the current through L1 will be basically, yes, there is L2 on the top, L1 plus L2, V by R, perfect. And next one, after a long time, the current through L2, I think there is a printing mistake over here. Let me just correct it. Will be, I think this should not have been there. Yeah, will be this particular thing. And I think it should have been L1 over here. I think there is a printing mistake if I'm not wrong. Yeah. So then this will be definitely correct. Yeah. These are the correct options. Is that right, everyone? Yep. I think there was a printing mistake over there. I think it should have been for L2, it will be L1. For L1, it will be L2. Exactly opposite. Yeah. For current through 2 will be having L1, current through 1 will have L2. Is that clear, everyone? Yeah. So for VIT Triple A also we are getting the sessions, Sugant. Don't worry about it. Yes, the sessions are coming. Awesome. The book is so good. I'm so glad, Mohan Raj. And for those of you who are wondering which book is Mohan Raj talking about, he's talking about exactly this book. Okay. So this is an amazing book. And trust me, even teachers love it. Even I love solving through this book personally. I have solved it 2 years back when it was first started. And then, I'm also looking at some newer questions which were added in this particular book this year. In fact, I can conduct a special session just on the rank accelerator book in the next coming days. It will be very useful. So buy this book, guys. It will get delivered immediately so that you can practice some unseen non-PYQ questions, because PYQs you will solve, but non-PYQs is very important. Okay. So let's go, guys. There is a circular insulated copper wire loop which is twisted in the form of two loops and areas A and 2A as shown in this figure. This is crazy problem. See, this loop is like this and it is like an 8 and there is a bump over here. So it is not having any contact. Okay. So that is what it is. It's like a figure 8, but there is no connection at that intersection point. Okay. They are insulated from each other. That is the meaning of it. They are not touching each other. Okay. A uniform field is in the plane of the paper and the loop starts rotating. Oh my God. Along with the diametrical axis. As you can see, this is that particular axis. So it is rotating along this particular axis. Interesting. And what happens is, if it is moving with constant angular velocity omega, which of the following options are correct? I think the options are on the next page because there was no space. Read through the options. Take a screenshot if you want, and then we'll come back. The EMF in the loop is proportional to the sum of the areas of the loop. The amplitude of the net EMF due to both the loops is the amplitude of the maximum EMF through the smaller loop. The net EMF is due to both the loops is proportional to cos omega t. The rate of change of the flux is maximum. The plane of the loops is perpendicular to the plane of the paper. Okay, crazy. All kind of options are there. Just have a look at it. Sir, I wasted 2 years. I got 940 marks. I may not get 30 the MSAT and 1 for the exam. Press. Chetu, if you think that really the reason for it is just the lack of practice and sincerity, please take a drop. Otherwise, if you think I cannot improve, I'll still be lazy, or maybe my potential only is definitely not there, you feel that from inside, then don't take a drop. Whatever college you get, go in a good branch, don't take a lower branch. Okay, and then just do well in whichever private government college you get. But if you really feel that genuinely I should have studied and I could have done it, please take a drop right now. Even if you don't get IIT next year, maybe NIT or maybe a good government college will be better than wasting your time in a random private college with not a great degree or not a great branch. Okay, so that's what my personal advice will be. Although I'll be making special sessions for these things, don't worry. Okay, so have you read through this? Yep. Have you read through this, guys? Okay, so let's go. Let's go. All right. So let's go, guys. All right. So have I kept just a figure? No, I've not kept any empty diagram. No issues. Okay. So let's think. How do we do? First of all, understand if for this particular loop, okay, because the loop is twisted, right? So you need to really understand this. It is like this. If for this particular loop, if you consider this particular shaded area and this particular shaded area for this particular loop, understand for any one part, maybe the flux is going inside. So maybe it is like this. Other loop, the flux will be going outside because of the area vectors. So for this particular loop, if I curl my fingers, maybe the area vector is like this. This is how the area vector is. But for that same loop on this side, the area vector will be downwards like this. But remember, there are two different sizes, if I'm not wrong. One is A and another is 2A. So this will be probably 2A bar. So that is how it is. Whereas if you look at the magnetic field lines, they are in a very simple direction. I mean, let's say if it is downwards here also. It's not like different. Okay, magnetic field is in the same direction. So here the flux will be negative, here the flux will be positive. So if you count the flux here, it will be B into, let's say, 2A. If you count the flux here, it will be negative. So it will be negative BA because cos 180 is nothing but -1. So if you ask me what is the net flux, it will be 2BA plus negative BA plus negative BA. So that is the net flux, which will just be nothing but B into A. Is that right? And I think there were some options about the amplitude EMF. Okay, and the EMF is proportional to the sum of the areas of the loops and all of these things. Which of the following options are correct? That is the question. Is that right? Okay. Now, if you ask me what is the net EMF magnitude wise is d phi by dt. So it will be nothing but, I think the magnetic field is going to change the angle continuously. So that is what will cause that EMF. Magnetic field will change the angle with the area vector because the loop is going to rotate. Similarly, if you ask me what E1 is, it will be nothing but d phi 1 by dt. And if you ask me what E2 is, it will be nothing but d phi 2 by dt. As you can see very clearly, this flux is BA, this flux is negative BA, magnitude wise it is BA, this flux is 2BA. So, can't you see this phi 1 magnitude wise is equal to phi? Magnitude wise phi 1 and phi are equal. So, if these are both equal in magnitude, so their derivative will also be equal in magnitude. So, they will be definitely equal in magnitude. They will be definitely equal in magnitude for sure. Okay, everybody clear? I think that is what is there in one of the options. The amplitude of the EMF induced due to both the loops is equal to the amplitude of the EMF in the smaller loop. So this one is basically the smaller loop, and this one over here is basically the net EMF. So definitely the amplitude of the EMF, net EMF, due to both the loops is equal to the EMF in the smaller loop. So definitely B option is correct. Definitely B option is correct. Everybody till this point absolutely clear? Okay. I think let's look at the first option also. It will be easy. The EMF in the loop is proportional to the sum of the areas. I doubt that, because what is happening when you find the EMF, which is related to the total flux, the total flux is coming as BA and 2BA subtraction. So can you see the areas 2A and A are not getting added to become 3A, rather 2A and minus A is coming because the area vectors are in the opposite direction. So understand this very clearly. The net effective area is basically 2A minus A, which is basically A. So saying this is your net area. So saying that the EMF in the loop is proportional to the sum of the areas. This is definitely wrong. It should have been the difference. It should have been the difference of the areas, 2a minus a. So this is definitely wrong option. Okay, so this is definitely wrong option. Is this absolutely clear? Net area is 2a minus a, not 2a plus a, because of the direction. So this is also absolutely clear, I believe. Very good. Now, what about the next option? Where is it? The net EMF induced, the rate of change of flux is maximum when the loops are perpendicular to the plane of the paper, and the net induced EMF is proportional to cos omega t. Okay, now this is crazy, guys. This is crazy. What are you going to do for the net EMF induced in both the loops is proportional to cos omega t? Is something given to us? Let's see. At t is equal to 0, the loops start rotating. Okay, so for that, I have an idea. See, I'll tell you what. Initially, let's say if the area vector is like this, even the magnetic field is going to be like this. After some time, because they rotate, the magnetic field will still be over here, whereas the area vector would have gone over here, and this angle would have been omega t. So flux will be, net flux will be, this is, if this is net area, net flux will be B net area into cos omega t. Okay. So net area, we just figured it out over here, is nothing but A. So it will be nothing but BA cos omega t. This is your net flux. So what will be your net EMF? It will be derivative of the net flux, derivative of the net flux. So it will be nothing but BA with a negative sign, and omega will also come outside. Derivative of cos is nothing but negative sign omega t. So that is what the net EMF will be. Okay, that is what the net EMF will be. So definitely it is proportional to sine omega t, not cos omega t. So net EMF is proportional to cos omega t. Definitely wrong. This should have been, instead of this, it should have been sine omega t. So definitely C option is wrong. The rate of change of the flux is maximum. Rate of change of flux means EMF is maximum when the plane of the loops is perpendicular. So d phi by dt, this is basically your rate of change of flux. This is nothing but rate of change of flux. Rate of change of basically your flux. I want to have a maximum value of the rate of change of flux. That means sine omega t should be basically maximum. If I want maximum value of this, obviously this should be maximum. So if sine omega t is maximum, think about it, cos omega t, cos omega t will be minimum. Cos omega t will be minimum. Cos omega t will be minimum when, think about it, cos is minimum magnitude wise. I'm not talking about sine wise. We're talking about minimum magnitudes, not about the absolute values. Yes, cos 90 is 0. That means the angle should be basically 90 degrees between the area vector and the magnetic field. Area vector and magnetic field, the angle should be 90 degrees. So let's see whether it is there. When maximum, when the plane of the loops is perpendicular, to the plane of the paper. That means the area vector is definitely perpendicular to the magnetic field. Yes, definitely. This is the correct answer. Yeah. So when these loops become like this, the area vector will be in this direction, magnetic field is in the inside direction, they are perpendicular, exactly what we are expecting it to be. So definitely the correct answers are B and D. Everyone? Okay. Uh, because JEE is there, no, Karthik. So how can I put the mock test 2 weeks before when JEE is there? So I also need to concentrate on JEE, means when JEE exam is going on, I cannot go on to any other mock test, right? Because everybody is preparing for JEE. So that's the reason. Okay, cool. So let's move on to the next question coming up on your screen. Here it is. There is a conducting wire which is parabolic in shape. Y is equal to x square, moving with some speed. I think that equal to symbol is missing. This is equal to. In a non-uniform field where magnetic field again equal to. B naught 1 plus y by L raised to beta. Okay, that is beta, not 8. That is beta. K cap as shown in the figure, where V naught, beta naught, B naught, L, beta are some positive constants. Delta phi is the voltage difference between the ends of the wire. Okay, and the correct statement is R. Okay, and the options given are over here. Crazy. Let's have a look if I just have the question. Yes, I just have the question. Okay, let's look at the options first. So first of all, see, the wire is in a curved manner. The velocity is in this direction. Magnetic field is in the K cap. That means towards you. You can see the dot. The wire is moving towards your right hand side. Wire is moving towards your right hand side. This is your velocity vector. Okay, so crazy guys. First of all, some beta is given, 5 flux change is given. Flux remains the same if parabolic wire is replaced by straight wire, or the flux change is this. Flux is proportional to whatever, okay, the length of the wire projected on that. Okay, and delta phi is the potential difference. Sorry, it is not flux, my bad. It is the potential difference, my bad. The potential difference is uh, oh, I think the D option is the crux of the problem. If I solve the D option, I think most of my job will be done. See, there is this concept which I think you should know. Observe this now. Imagine this is my wire. It is moving like this with some velocity, versus there is a wire like this which is moving in this direction. Magnetic field in both the cases is towards you. Magnetic field is basically towards you. Tell me, in which of these conditions will EMF be induced across the ends of the wire? Quickly think and tell me. Will it be here or here? Situation 1 or situation 2? Do you think motional EMF will be created across the ends of this conducting wire? I'm listening, I'm reading your chats. Quickly think and tell me, guys. Where do you think? Where do you think it will be? Sir, is it not minus d phi by dt? Yes, it is minus d phi by dt, but we are not interested usually on the negative sign when we are interested in the amplitudes, magnitudes, such things. So when you are just interested in the absolute mod values or amplitudes, we ignore those negative signs. It's fine. There is nothing. The question will not change just because I put a negative sign. Yeah. Obviously, only in the second one it will be induced. So in this case, there will be no EMF, a motional EMF basically, no motional EMF in this case, but only in this case, definitely there is motional EMF, and that motional EMF will be a very small value. That will be basically D, and it will be B dx or whatever that dy, whatever that length is, into velocity. So if this length is assumed to be dy, if this length is assumed to be dy, then it will be bl into v. That is what it is. So if I have a conductor which is at an angle, moving like this, inside that same magnetic field, it is now obvious that it is the dy part which will cause the EMF, whereas the dx part, which is the horizontal component, will not cause any EMF. So it's only the vertical component in this situation which is causing the motional EMF. That is the crux of the problem, I believe, because that is what I think D option is referring to. The potential difference is proportional to the length of the wire along the y-axis. Notice how the same wire is moving like this in this particular direction with some velocity. So this curved wire will have vertical component and horizontal component. So which component will matter and which component will not? Obviously, this horizontal component will not even matter. So there is no EMF because of the horizontal component, but it is only this particular component, which is the vertical component, which will have motional EMF contribution. Motional EMF contribution is only because of the vertical part. So the EMF developed is proportional to the length of the wire projected on the y-axis. So D option definitely is correct. Is this understood, everyone? Till this point, absolutely clear? Yep, perfect. D option clear, everyone? Yes, UG double is also coming day after tomorrow or something. Yeah, yes, definitely, Yashwant, it is coming, UG double E. Because last year also we did, this year also we are going to do it. Okay, cool. Now comes this part. I think we cannot do this part without actually solving the problem with integration and all of that, because some B value is given, velocity is given, crazy things are there. But one thing I know, I just need to worry about only the vertical part, not about the horizontal part. So I'm just interested in this particular section. And in that also, what I will do, I will take some random small segment which is having a value of dy, which is having a value of dy, and that is at a distance of y over here. It is at a distance of y over here. The magnetic field at that location, is B naught 1 plus y by L raised to beta. B naught, the magnetic field at that particular location, is nothing but B naught 1 plus B naught 1 plus y by L whole raised to beta. That is what the magnetic field is at that place. And obviously it is given that it is moving with some velocity over here, which is V naught I cap. Okay, perfect. So what do we do? First, find the small EMF which will be developed. The EMF in that element, will be dE, which will be magnetic field into dy into velocity. So the net EMF, E will be integral of d, which will be integral. Magnetic field is nothing but B naught 1 plus y by L raised to beta dy into velocity, which is again V naught. So that is what the net EMF should be. And because we are talking about the limits will go from 0 to L, the y coordinate limits. 0 to L for y coordinate. 0 to L. Okay, fair enough. So therefore, the EMF will be B naught is a constant, bring it outside the integral. So is V naught, bring it outside the integral. And I am left with now integration of just dy from 0 to L plus what is it? 1 by L raised to beta is there. Integration of y raised to beta dy is there, like this from 0 to L. Just check this out, guys. Till this point, absolutely clear. I've just done the normal integration part, nothing else. So now let's do that integration and see exactly how much do we get. E is equal to B naught V naught. Integration of dy will be y, so it will be L only, plus over here y raised to beta, integration is y raised to beta plus 1 by beta plus 1. So it will be L raised to beta plus 1 by beta plus 1. Do not forget this L raised to beta over here. That's it. Once I put the lower limit, it is 0. So I'm not substituting it. Mentally, you can do the math. The lower limit, if I put, nothing will happen because it is 0. So from this, I can see it is nothing but L plus L raised to beta will cancel. L divided by beta plus 1. So L is basically a common thing. So I can take it out. So B naught, V naught, L, and then we have 1 plus 1 by beta plus 1. So that is basically your EMF. That is basically your EMF. Okay. So is that option there somewhere? Let's have a look. The EMF is, oh no, they have given special values. But before that, let's see what are the values which are substituted. Beta is 0 and beta is 2. So let's substitute that and see. Beta is 0 and beta is 2. So if I substitute beta is equal to 0, what will I get? B naught, V naught, L, and then we'll have 1 plus 1 by 0 plus 1, which will be, correct, 0 plus 1. So this will be 1 plus 1, which is 2. So 2 B naught V naught into L. Okay, that is one thing. And if I substitute beta as 2, then what do I get? beta is 2. So B naught V naught into L, 1 plus 1 by, so instead of 0, I put as 2. So 2 plus 1, which is 3. Okay. So 1 plus 1 by 3 is nothing but 4 by 3. So it will be 4 by 3 B naught V naught into L. So let's see whether those numbers are there actually. Yes. So beta is equal to 0. It is half B naught V naught L. That is definitely not correct. Can you see that, guys? Definitely it is not correct. I should have got 2 times of that. So C option is wrong. As you can see over, where did it go, yeah? Mm, yeah. So C option is definitely wrong because I should have got 2 over here. What about A option? Beta is equal to 2. Beta is equal to 2. Yes, 4 by 3 is definitely there. So when you put beta is equal to 2, definitely this is matching. But beta is equal to 0, it should have been 2 times of that. By mistake, you might think this is correct, but no, it is not correct. It should be 2 times of that. Is that right, everyone? Very good. Till this point, absolutely clear. Okay. Now comes the last thing. The flux remains the same if the parabolic wire is replaced by a straight wire y is equal to x initially of length root 2L. Okay. Interesting, guys. I just mentioned it right over here. Where is it? Yeah, right over here. That only the vertical component mattered in this curved wire. The shape, the curvature never mattered. So imagine somebody had replaced it with another wire, just looking like this, obviously the equation of this line will be y is equal to x. The height, if it is L, the length will be obviously root 2 times of L, because height and width both will be the same. Whatever EMF will be generated here will be generated in the curved wire. So the curved wire will be equivalent to the straight wire with the same ends. With the same ends, they will generate the same EMF. They will generate the same EMF. Only the vertical component matters. Even if somebody had made another weird looking wire like this, but if the ends points were same, the vertical parts are same, that's it. It will still create the same EMF. Okay. So hence the correct answer for this is definitely B. Flux remains the same, whose length is root 2L if you replace it with a straight wire. Is this clear, my dear students? Perfecto? Amazing? Done? Dusted? Yes. So A, B, and D. What a beautiful, beautiful conceptual question. Right. Sir, shall I repeat? Physics 43, maths total 81 by 100, 7th SH2 last, wait, 8 minute. Uh, Harish Charan, can you put that as a comment? It will be better for me to reply. It's little difficult during an advanced session for me to think, analyze, and do all these things. Okay. Harish Charan, please put it as a comment. Yes. So, yes, Siva Prasad, it will be same. Thank you, Soumya. I'm your fan from Tamil Nadu. Just 7 more days left for VIT Triple E. Can you suggest for any physics playlist? It is there in the thing only. Please check it out. It's just search for VIT Triple E in the search bar, not through mobile, through website, preferably here. If you just search for VIT Triple E here, you will get all my lectures of last 2-3 years. Okay, so just use that search bar over here. Okay, very simple it is. Okay. Moving on to the next question coming up on your screen. There is a conducting loop. Oh, guys, by the way, I think you would have forgotten to smash the like button by now. Please, just a gentle reminder, smash that like button. It's down there. It's going to take you 0.5 seconds, maybe. Quickly smash it in case you have forgotten to do that. And some people also forget to subscribe, keep watching videos, and they depend on YouTube to recommend you. Come on, guys, don't be that lazy. Subscribe to the channel also. Okay. Thank you so much. Okay, so there is a conducting loop of a right angle isosceles triangle of height so and so 90° at the vertex close to and very long wire as shown. The wire is electrically insulated from the loop, so it is not touching, although it feels like it is touching. The hypotenuse of the triangle is parallel to the long wire. Current in the loop is, oh, there is a loop current which is there, not in the wire, and it is changing, it is increased at a constant rate of 10 ampere per second. Which of the following statements is are true? which of the following statements are true? Come on, guys, let's think about this. Where is that statement? Oh, the statements are here. The EMF induced is mu naught by pi. If the loop is rotated at some speed, additional EMF will be generated. The induced current is opposite and there is a repulsive force. I think to find the force, I need to know the direction of the current. That means I might need option C to solve D. And before I get to that, I think it's better to find the magnitude of the EMF and why it is coming. And then maybe think about whether additional speeds will give me additional EMF. So I think first we'll solve A, then we'll go to B, then C, and then D, very sequentially, because that's what I think might give us the correct answer. Okay, so first of all, anything else given? Yeah, current is increased at a constant rate. Okay, fair enough. Now, the problem over here, I'll tell you what it is. The current is flowing through the loop, and is the direction given? Current in the counterclockwise, that means anti-clockwise. Okay, see, current goes like this, like this, like this. This is that current, and it is increased for sure. It is increased for sure. So this particular loop then becomes the primary, and obviously whatever current will be induced over here, I don't know what direction will it be. Chumma, I'm assuming some direction. So this particular will be the secondary circuit where the EMF is induced, And if you notice, the question or the option says the current in the, the EMF in the wire which is induced is mu naught by pi. I feel to find that EMF, I will need the flux, which is very difficult to calculate. Instead, I can find the mutual inductance, which I do not know. But I know one thing, if this is primary, this is secondary, definitely it's going to be a crazy thing to find the mutual induction between the two wires. Rather, so since it is now a difficult problem to find the mutual inductance. How about this, guys? Just check this out. How about this? Make this as your primary. Make this as your primary current. Make this as your primary current just for the sake of mutual inductance. And then let this be the secondary. Let this be the secondary only to find mutual inductance, because mutual inductance of 1 with 2 or 2 with 1 is the same. Yeah, it is the same. So that is a small trick which we use to conveniently find mutual inductance because of the reciprocity. That means they are equal. So it doesn't matter whom you make primary. So just for that time being, let's do that. Okay, so if I'm doing that, I need to find flux to find mutual inductance. So to find flux, I have an idea. This current will produce a magnetic field around it. And the magnetic field, let's say if the current is going like this, will go like that. Here, it might be very strong. Over here, it might be even stronger. As you can see, it is stronger. As you go here, it might slowly start becoming weaker. Here, it might become very weak because the distance has increased drastically. So the magnetic field is changing with distance. So I have an idea now. Let's take a small strip. Let's take a small strip of wire, strip of area. And that strip of wire is, let's say, at a distance of, let's say, x over here. And because this is 90, it's an isosceles triangle. If this is x, even this is also x, and even this is also x. This is also x, and even this is also going to be x. Everything will be x. And the magnetic field over here, the magnetic field which is there over here, that magnetic field will be due to an infinitely long wire carrying current. So mu naught I1 by 2 pi x. 2 pi r is the distance from the wire, so it is 2 pi x. Okay. Then what is the height of this basically? The width basically of this will be nothing but dx. So the small flux through the element, through that particular element, through that particular element, which will be d phi. I will need it because only integrating the flux, I will find the total flux. And why I need integration? Because magnetic field is not constant. So I have to use integration. Will be the magnetic field at that location into the area of that particular rectangle. The area of the rectangle will be width into height. So width is nothing but 2x multiplied by height, which is dx. So this is the area of rectangle. Area of rectangle, which we just wrote, width into height. Everybody fine till this point? Yeah. All right. VIT also is coming, Jaya. I know VIT triple is also important. JEE Advanced is also important. How much? If I do one thing, the other thing goes. That's the problem with engineering entrance tests, right? There are so many tests. And how much can Shreyas Sir also do? Whatever I have done, also that you should watch last year, 2 years back. Also, plus I'm on the NEET channel, plus I'm on the Maharashtra channel for JEE. So guys, lot of things are there, but definitely I will do, my dear students. I'm working very hard for all of you. Definitely I will do it. Okay. Yeah. So let's integrate this. Yeah, let's integrate this. Nothing else is there. Okay. So before integration, I will just write over here phi is equal to integral d phi. Oops. Integral d phi, which will be integral magnetic field. How much is it? Mu naught I1 divided by 2 pi x. And this thing will come as it is, which is 2x dx. And it will go from 0 to this. This is 10 centimeters, which is obviously zero point 0.1. Do in SI unit, 0.1 meter. Okay. So let's come back over here. 0 to 0.1, of course. Mu naught is a constant. 2 and 2, x and x gets cancelled. Can you see that? This 2, this x and this x just got cancelled. So what am I left with? This is scary, guys. What is left with? Mu naught, I1 is remaining, pi is also remaining, and just dx is remaining. So from 0 to 0.1. Well, we know this very easily. That is nothing but just x. So it is 0.1 minus 0. 0.1 is 1 by 10. So it will be mu naught I1 by 10 pi. So that is your flux. So flux is proportional to the current. So it is obvious now that this particular part is nothing but your mutual inductance. Mutual inductance. This is your mutual inductance. So mutual inductance is mu naught by 10 pi. And why is it mutual inductance? Because flux is directly proportional to the current. The constant of proportionality is called the mutual inductance. So this is one very important thing which we got. But that is not even asked in the question. So now let's come back. So because now it was difficult to find M like this, I have now found out that M. So it was earlier difficult to find M, but from the next modification, manipulation, what did we get? That the mutual inductance is mu naught by 10 pi. That is what we got, mu naught by 10 pi. So now I think we can find out every single thing, whatever we need. Yes, now we can find out everything, whatever we need. So first of all, let's look at the options. Where did the options go? Yeah, here. The EMF in the wire is this much. Okay, so I know what to do. The EMF in that wire, E2, will be M di by dt. M di by dt. Mutual inductance, how much is it? Mu naught by 10 pi. This di1 by dt, this is what I'm talking about. So this is basically your I1. This is di1 by dt, but that is also given to me. Look at it carefully. It is increasing at a constant rate. So di1 by dt is 10 ampere per second. So that is the rate at which the current is changing in that triangular loop. So I know that current already di1 by dt is 10. So 10 will cancel. and I am just left with mu naught divided by pi, which is the EMF in that particular wire, that long wire. So definitely I can mark this option correctly. Everyone till this point absolutely clear? Beautiful question, isn't it? Okay, now let's go to the second part. This is even more beautiful. Observe it. The loop is rotated at a constant angular speed about the wire and additional EMF will be generated. Now see guys, just think about it. Maybe I can show this diagram only. If you rotate this wire, just imagine this now. Okay, imagine this wire is there, but this particular part earlier was here, then maybe it will go here, then after some time maybe it will be like this in that plane. Yeah, then it might go like this, then it might go little difficult guys to draw, then it might come like that. So it is basically rotating. It is basically rotating. If it rotates, what difference does it make? I mean, the magnetic field lines are also going like this. The same magnetic field lines are going like this. So the number of field lines is still going to be the same because they are circular field lines, circular loops. So that means the flux is still going to be the same. Therefore, the EMF which you are expecting will not be there because of that rotational motion. So saying that there will be an additional EMF, this additional EMF will not be there because of the rotation. Because of this rotation, it will not be there because the same field lines will still go no matter whether the loop is like this, like this, like this. Same field lines are circulating. So no additional EMF. Is that right, everyone? Okay. Now let's go to the last two parts. So B option definitely has been eliminated between C and D. Current in the wire is opposite to the current along the hypotenuse and they will repel each other. The current in the wire is in the opposite direction or is it in the same direction and will there be a repulsive force? Okay, so for this particular thing, coming back over here, what will you do guys? Think what is the logic for predicting the direction of the current? Yes, think what will be the logic for the direction of the current. The current is definitely increasing. If the current is increasing, what do you think will happen? This wire will create a current in such a way. Think like this. This is your primary. It is increasing the current, right? It is increasing the current. So the magnetic field due to this wire, curl your fingers, it will come towards you. So this particular flux, the flux outward will increase, but by Lenz's law, the magnetic flux should reduce. So the induced flux, so the induced flux will oppose the particular change as per Lenz's law, as per Lenz's law. So the magnetic field is going inside because of the wire which is present here. How should the current be? Think about it. The magnetic field should come like this. It should go like that. It should go like this, isn't it, everyone? So the magnetic field will come towards you on this side. It will go like this and it will finally go over here. That is how the field line should be. So only if the current goes towards the right side, only if the current goes towards the right side will the magnetic field be like this. So the current will be in this particular direction, the induced current. So it will be in the same direction. So I think they have mentioned opposite direction. The current will be opposite direction along the opposite hypotenuse. No, it is definitely going to be, no, not opposite. It will definitely be same. It will definitely be same. Is that right, everyone? Where did it go? Yeah, it will be in the same direction. And what happens when currents are in the same direction, guys? We all know this. When currents are in the same direction, what will they do? They will always attract each other. they will always attract each other. So is that mentioned? There is a repulsive force between the wire and the loop. Definitely no, there will be an attraction between them. Yeah, yeah. So they will be in the same direction. So definitely there will be attraction between them. Okay, not repulsion, not repulsion. So this will be attraction, attraction. Is this absolutely clear? So D option is correct, everyone. Opposite wires will repel and same direction currents will attract. Yep, attractive. Okay, very good. All right. Like series chapter wise, Soumya, we have never done for VIT triple E because the syllabus is the same, right? So that's why we have never done that. Almost similar. So we have usually done mock tests or question practice in general. That is what we have done. Let's go to the single correct option questions. Here comes the first question on your screen. Read this question carefully. Two particles are there of the same mass and having same magnitude. One particle is at rest and the other is moved towards the other particle projected impact from a very large distance, the distance of the closest approach. This concept is based on the modern physics chapter of atomic structure, more specifically your Rutherford's model, where the approach distance and all those concepts come. But over there, what happens? The nucleus is heavy and the alpha particle is quite small as compared to the nucleus. Here, the particles are identical. That is a big difference. That is a big difference. Okay. So how do we solve this? I think let's keep a blank slide and start thinking about it. First of all, mass m having same magnitude of charge, they are on rest and they are towards each other from a very large distance. Okay. So this is charge q. This is also charge q. Their separation is infinity. Large distance is given. Large distance. And it is thrown with some velocity. Velocity is v, that is given. After some time, what happens? They will come close. They will start repelling and they'll start moving. When they start moving, there is relative motion between them. Just imagine you are sitting on one of the charge and looking at the other charge. And if you find a relative motion, that means the distance is reducing. So this is very, very important in the understanding of the problem, that if the distance between the charges is reducing, if the distance between the charges is still reducing, that means definitely there is relative motion. Relative motion is still going to be there. Only when there is relative motion, that's why the distance will be there. The distance will not change anymore, and that will be the closest when both of them have the same velocities. That is, there is no relative motion. And in that case, that particular distance, let's say I call it as d, will be the closest distance of approach. Think of it like this. If I'm sitting on the charge here, I look at the charge there. That charge approaches, comes close, stops, and goes away. So when it is the closest, it has stopped with respect to me. Stopped with respect to me means relative velocity is zero. So if the relative velocity is zero, that means both the velocities are going to be the same. Is that clear, everyone? Yes, there is going to be a batch for 2026. We'll be announcing it very soon. Okay. Since we are right now extremely busy and heavily occupied with 2025, which we will be occupied for 2026 next year, same time. So I hope you understand it, guys. These people need our support, lot of support. And there are many exams. It's not just one JEE mains and done. We had triple EKCT, COMED, so many. Okay, BitStat, SRM, VIT triple E, JEE Advanced. So many things are there. So understand it, please. Okay. So now, using this idea, I have a feeling, why not conserve the momentum of the entire system? So let's use conservation of momentum. Conservation of momentum. And the reason why I can conserve momentum is because the electric force is internal. Electric force is basically internal. Externally, there is no force, so I definitely can conserve the momentum. So I'll put equal to symbol over here. What is the initial momentum? Only this mass is having some velocity, the other mass is not having any velocity. Finally, both of them are moving with the same speed. So mv1 plus mv2. M cancels, so it will become basically 2v1. And over here, just v will be there. M has just got cancelled, as you can see from here. So therefore, from this, I will get the value of V1 is V by 2. That is one important part of this relationship. So V1 is V by 2. We have got it. Next, let's use energy conservation, guys. Okay, momentum is there. Energy is also conserved. So conserve energy. So conserve energy and see what exactly we get. Conserving energy. So we know initial kinetic plus initial potential will be final kinetic plus final potential. So let's start with initial first. Only kinetic energy is there, which is half mv square. Potential energy for infinite separation is always going to be 0. Next, when you come close by over here, kinetic energy is there for both. So half mv1 square, but there are two such particles, so into 2. Potential energy is Coulomb constant. I think Coulomb constant is there in the options, or 1 by 4 pi epsilon. Okay, fine, we'll substitute it later. K q q divided by the distance. Okay, perfect. So maybe I can start substituting things and we'll get the answer. All right, so let me do this on the next slide over here. Okay, so first let's see what will happen on the left hand side. Left hand side will remain as it is only. So half mv square will be there. So half mv square is there as it is equal to, check this out, on the left hand side, 2 and 2 will cancel. Mv1 square is there. M times v1 square is there, but v1 is v by 2. So it will become v by 2 whole square plus, is that right? So 2 cancelled. I hope you can see that right over here. This 2 and this 2 cancelled, and this v1 I substituted it from here. Okay, I put it over here. Okay, and kq square by d. Okay, last thing is kq square by d. K q square divided by d. I want d, so bring these people over here. So k q square divided by d will be, when I shift this guy here, it will be half m v square minus 1/4 m v square. So half minus 1/4 is 1/4. So mv square into 1 by 4 is k q square by d. So d will be equal to, d on the top, 4 goes on the top here, 4kq square divided by 4kq square divided by mv square. But k value I know is nothing but 4 pi epsilon naught, and this mv square will be there. 4 will cancel, so it will become q square by pi epsilon naught mv square. By pi epsilon naught mv square. Where is it? But I think they have not cancelled the 4. Yes, guys, which option is correct then? Obviously, A option. Can you see that? Yes, A option is correct. If you don't cancel the 4, then you can see right over here, 4q square, 4 pi epsilon naught mv square. Rest all the options, something or the other is wrong. Like m square is there, or here 2 is there. Something or the other is wrong. So only A option is the most appropriate option. Very good. No, Jivantika, the option is not B. Option A is correct. Soumya, you're looking so tired, so go take rest. I had my dinner, Soumya. Thank you so much. And I don't know how you guys figure out that Shreyas sir is tired or not tired, but I'm so glad, guys, you think about all the teachers. Okay, all right, right. So let's go, guys, to the next question coming up on your screen. Oh, this is the question. This is the question. A rigid wire, loop like this. Side length is L, resistance is R, along the x-axis with constant velocity v0 at t is equal to 0. The right edge is just entering the region of length 3L where there is uniform field. Now, sufficiently large speed is there, so that means it will not stop somewhere in between. The loop eventually crosses. See, if the speed is not much, I think it will stop somewhere because of eddy currents and all of that. Anyways, coming back. So let V be the speed, Ix be the current, and Fx be the force as a function of x. Counterclockwise, anti-clockwise is positive. Which of them are correct? I think this is multiple choice. By mistake, I put it in the single correct. No issues. Let x be the location of the right edge. So the right edge is having the coordinate x. So which of the graphs will be correct? Okay, these are the graphs. This is of current, this is of force, this is of velocity. Interesting. Okay, guys. I think let's look at options and we can easily start eliminating it. Yeah, we can. Maybe it is not multiple correct, it was single correct only. Maybe, yeah, we'll see. Figure out. First of all, first of all, hmm, when you enter inside, think the flux will increase. So the current, what will happen? When you enter inside, what will happen? The flux will increase inside. So to oppose it, there will be an induced field in this direction. This will be the induced field opposing it because the flux is increasing. So for that, the current should be in the anti-clockwise direction. It should be in the anti-clockwise direction. That means it should be positive. And exits outwards, as it exits outwards, just like here, the flux was increasing. As it exits, the flux is decreasing. So it will strengthen the flux. So the induced field will be inside. The induced field will be inside to help it strengthen it because it is decreasing. So if you point the thumb inside, the curled fingers will be in this direction, which is clockwise. So it will be negative as per the sign convention. Counterclockwise is positive, anti-clockwise is positive, clockwise will be negative. So the current will be positive, then negative. In between here, can you see that the flux is basically constant? So EMF will be zero, current will also be zero, and even the velocity will be constant over here. Nothing will change. No current, no power, no work, no electricity at all because the flux throughout that region will be constant. So positive to negative and zero. Positive, positive, 100%. See, this is positive, this is also positive, 100% A is wrong. Okay. Now, what about C option? Here it is positive, here it is negative, in between it is zero. Seems to be correct. Maybe it is correct. But I don't know whether the current will decrease like this, the way it has been shown. We'll think about it in a bit. We'll come to that. We'll come to that. Okay. We do not know yet whether that current will change exactly the way it has been shown. Everyone? Perfect? All right. Okay. Okay. Now, what do we do now? What do we do now? Next. One second. Okay. Now, where were we? What about the force and what about the velocity? Can we eliminate any of these? I think so. We can. What is F? F represents the force on the loop. If you look over here, when it is entering inside, the force will be this way, negative side. And here also it will be negative side. The force will be the same direction. When it is entering inside, the force will be like this. Here, the force will be zero. When it is exiting out, also the force will be here only. So the force cannot change the sign. So how can the force be negative and then positive and then zero? No, it has to be the same sign. So B option is also eliminated. B option is also going to be eliminated. Is that right, everyone? Till this point, clear? Absolutely. Yep. Very good. Very good. Very good. Now comes the next part, velocity. I think velocity will remain constant. It will decrease and again it will further decrease. This seems to be very, very correct. But how do I eliminate between D and C? How do I eliminate between D and C? Because I know the current will be once positive and then it will be negative. But how do I know that D is correct or C is correct? Any suggestions, guys? Come on, everyone. Come on. Phoenix, you want to take revenge on whom, man? Come on, guys. Think about it carefully. How will you eliminate this? How will you eliminate this particular option? Think carefully, guys. Think carefully. What are you going to do? Yeah. I2, WL, EMF is 0, L2. Think, guys, come on. Again, what will happen? 2026 batch watching my sessions. Thank you so much. Oh my God, already into my sessions. Think, think. The current, the current, will it be decreasing or will it be constant? The current, will it be decreasing or do you think it will be constant? Sir, L to 2L, EMF is 0. L to 2L, EMF is 0. Okay. Yes, it is definitely 0. No issues. Even 2L to 3L. In fact, only when it starts coming out over here. So 0 to L, it will keep on changing. From L to 3L, it will be constant. And from 3L to 4L, it will be again decreasing. Well, I feel over here, what we should see. Notice, guys, 100% it is there that the velocity will reduce. Then the velocity 100% should be constant. And again, the velocity will definitely reduce. If you talk about the current in this particular circuit, the current will be BLV divided by the resistance. BLV is the motional EMF, R is the resistance. So as per that, your current will keep on changing. Is that right, everyone? Yes, is that right? Everybody with me? Correcto? Okay. Now, if the velocity reduces linearly, if the velocity reduces linearly, think about it. Think about it. Even, even the current should reduce linearly because magnetic field is constant, L is constant, R is constant. The magnetic field is uniform everywhere. It is a uniform magnetic field. So velocity will reduce, current will also reduce. Okay. If you see over here, velocity further reduces. If velocity further reduces, current should further reduce. Oh, here also, from this point to this point, the value of the current is reducing linearly as per the velocity. So if this has to be correct, if this has to be correct, even this has to be correct then. And the current first is positive and then it is negative. What exactly what we are expecting? First, the current is positive because the flux was increasing to give a opposite flux. The current is in the positive direction, then it is in the negative direction. Exactly what we are expecting it to be. B, L, and R are constant. So obviously, then C and D will be the correct options. Got it, everyone? Yep. Awesome. 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 So, as you can see, my dear students, these questions are very conceptual, deep. Sometimes you don't have to calculate much. It's just about how you are visualizing things. Okay. Okay. I thought V as potential difference. No, V is not potential difference. V is what is it? V is your speed, velocity. Okay, great, cool. Let's move to another question out here, which is, yep, integer type. I think yes, numerical type value. So let's go to numerical type questions coming up on your screen. Okay, what does it say? There is a long wire moving with some speed and horizontal rails are there. This wire is moving with some constant speed, I think. One side is connected to an inductor, resistor. Horizontal rails L and R are in the same plane. Uniform magnetic field is there perpendicular to the plane inside. So you are closing the switch at some time after 1 millisecond. After 1 millisecond, the current is how much? That is the question. Assume the velocity remains constant after the ski is closed. Given e's values to the negative power 1 is 0.37. E is the base of natural log. Yeah, okay. So let's see if I can get a new diagram on the next slide. No, I don't have it. So I'll have to redraw it. No other option. Okay. This is how it is. What else is there? Inductor and resistor is there. Okay. So there is an inductor and a resistor like this. What is the value of the inductance and the resistance? 1 and 1. 1 millihenry. 1 millihenry. This is 1 ohm. The velocity is given to be how much? 1 centimeter per second. So 10 to the power minus 2 meters per second is the length given. 10 centimeter long. That means it is 0.1 meter. So it is 0.1 meter in length. Okay, and magnetic field, I think that is also given to me. Magnetic field is 1 Tesla inside. So the magnetic field over here is 1 Tesla. Okay, so I can say that this rod which is moving acts like a battery, motional EMF concept, and that motional EMF E will be BL into V. B is 1, L is zero point 0.1, velocity is constant, so 10 to the power minus 2. So EMF will be 10 to the power minus 3 volts. That is what I will get. Now the remaining part. Okay, so the remaining part of the circuit basically just has one inductor, one resistor, and like this. So this is 1 ohm, this is 1 millihenry. Now this is a LR circuit. And when you close the switch, this particular switch, where is it? The switch when it is closed. So this particular switch, when you are closing it, okay, when you are closing the switch, this is the growth of current. This is basically the growth of the current in a LR DC circuit. In a LR DC circuit. That is what it is. So it's a growth of the current in a LR circuit. And the question is exactly finding that the current after some time. What is the value of the current in this particular circuit after some time? What is the function, guys? Do you remember the formula for the growth of the current in a LR circuit? Everyone? Come on, guys. What's the formula? Yep. The current formula is nothing but what? What is the formula? It is maximum current that you reach, which will be nothing but E by R into 1 minus e to the power minus RT divided by L. That is what the formula is. Isn't it? That is what the formula is. And do I know E by R? I think we know E by R value. EMF is nothing but 10 to the power minus 3. Resistance is nothing but 1 ohm. 1 minus e to the power minus R is nothing but 1. L is nothing but 1 milli. So 10 to the power minus 3. The time is also given, I think, after 1 millisecond. So 1 millisecond time will be 10 to the power minus 3. So this will become 10 to the power minus 3. 1 minus e to the power just minus 1. But wait a minute, something is given over here. E raised to minus 1 is 0.37. That's already given. So 1 minus 0.37. So this will be 10 to the power negative 3 into 0.63. And I think I can now write it as 0.63 into 10 to the power minus 3 is basically the current in amperes. And that is what is asked. The current after 1 millisecond is something into 10 to the power minus 3 amperes. So minus 3 should have been there. Yes. So then it will be 0.63, guys. So it is 0.63. Perfect. That is the correct answer. Everyone? Perfecto? Yep. Yeah. So this power was supposed to be minus. I think that minus was not printed over here. So let me print it. Cool, guys. Very good. Very good. Yes, 0.60. Yes, it is 10 to the power minus 3. It's me Rajamani. Yes, Rajamani. It is minus sign. Minus. All right. All right. Very good. Very good. Awesomeness. Shall we go ahead to the next question coming up on your screen? Let's go to the next question, guys. Here it is. What does it say? Oh my God, crazy. Two circuits, inductors, batteries, resistors, switches, so many things are there. There are two LR circuits around each other. Self-induction is given Okay, mutual inductance is also there. My God, both the switches are closed. The total work done by the batteries against the induced EMF in the inductors by the time the currents reach the steady state values. Do I have only one diagram? Okay. So I close the switch. Let's see what happens. Observe carefully. The moment I close the switch, the current will go like this, and there will be a flux in this particular part of the wire. And this particular battery, when I close the switch, the current will again go like that. The current will go like this. From here, the current will go like this. Okay. So in this particular inductor, the magnetic flux is going like this. Because of this current, mutually, because it will generate a magnetic field, that magnetic field is entering exactly in the same direction. Can you see that? It's exactly entering into the same direction, passing through itself like this. And at the same time, this guy's current passes through this guy, enters over here in the same direction, and it comes out like this from over here. This tells me the mutual coupling between them is supporting the self coupling, or it's not self coupling, the self inducted flux which is there. This is very important just because of the manner in which the batteries are connected. So I can just conclude over here, the self flux is in the same direction as of the mutual flux, which is a very critical part of the particular problem, because if the directions are opposite, then the flux will cancel, the EMFs will be different, the currents will be different, everything will change in the problem. And the question says find the work done, that means you have to find the energy stored. Now, energy stored in the inductor, we all know, is half Li square. But the problem is there is mutual inductance also. So if it was just self-inductance, energy stored will be half Li square. It will be a very easy problem. It will not be even a JEE Advanced question. It's a JEE Advanced question. Mutual inductance is there. So we need to think about it, guys. Okay. So if you take the left side inductor, if you take the left side inductor, so inductor number 1, the flux through it, the EMF through it, the EMF through that will be L1 di1 by dt plus M, mutual inductance, but this will be di2 by dt. That is what the EMF will be. So the power which will be there in that particular inductor, which is E1 into I1, will be L1 I1 di1 by dt plus M I1 di2 by dt. That is the power. And power, like we all know, is the work done per unit time. So therefore, I have an idea. Why not cancel dt and dt from both the sides? And I will definitely get, therefore, dw1 will be L1 I1 di1 plus M I1 di2. Same way, I can do it for the other guy. Similarly, I can say dw2 will be L2 I2 di2 plus M I2 di1. Just change the variables. Wherever 1 is there, you put 2. Wherever 2 is there, you put 1. That's it. So these are the work done in inductor 1. This is the work done in inductor 2 because of self as well as the mutual inductance. So obviously now the next step is adding both of them to find the total work. So the net work which is done, which will be dw, will be addition of all these people. So we will definitely have L1 I1 di1. We will also have from here L2 I2 di2 and there is one strange term which is over here. I'll put it in different color. Check this out. M I1 Mi1 di2 plus mi2 di1. I have an idea over here. If I take m common, then this will be mi1 di2 plus i2 di1. So what I will do, this small work will be, you put this as it is, L1 I1 di1. Okay, fair enough. This also you put L2 I2 di2. The last term, I have an idea. There is a reason why I did it like this. I1 di1 plus I2 di2 di1. What is this exactly? This is just derivative of I1 I2, UV rule. First function, second derivative, second function, first derivative, UV rule. So it is di1 di2. di1, sorry, I2. It's UV rule. Everybody agrees with this? This is nothing but your product rule of derivatives. Now, just have to put integral symbol everywhere. Integral, 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 integral. So what do we exactly get? Observe carefully. This will be now the total work, which will be obviously having i's integration is I square by 2. So half L1 I1 square plus this guy I2's integration is I2 square by 2. So half L2 I2 square plus the last one will be just M I1 I2. It's like dx's integration is x. So it will be M I1 I2. Now I think everything you know currents, voltages, resistances, everything. Like for example, in this part of the circuit, the current I1 will be V1 by R1. V is 5, R is also 5. So 5 by 5, which is 1 amperes. Same way over here also, you know the value of the current. This current will be V2 by R2. So it will be 20 by 10, which is basically 2 amperes. So you know the current I1, I2. You know current I1, I2. You know L1, L2. You also know, you know inductance L1, L2, and you also know mutual inductance. So this is 10 milli, this is 20 milli, everything, 5 milli, everything just substitute it. I think you will get the answer as 55 millijoules. Okay, after solving, you will get the answer after solving as 55 millijoules. Everybody loved this question? Yep. Yes, remembering is easy. Yes, that is the correct answer. It comes out as 55 millijoules. But the trick part of this problem is not, see, half Li square. The tricky part is this mutual inductance, how much energy is stored. Because nowhere in the syllabus, the energy stored in the mutual inductance is given. So at that point of time, you have to think, how do I do it? So that's why derivations are important. So many people ask, sir, is derivation important? Obviously. Will they ask derivations? No. But will they use derivations based questions? Yes. So if you knew how inductor's energy stored is derived, you can obviously find the energy stored in mutual inductance also. So it came out to be M I1 I2. Is that right? Okay. So that was the answer, guys. Yep. This is a homework question. This is a very straightforward question. It's just lengthy. So I thought, why not give it as homework? So basically, there is a square loop on the axis of a circular coil, and the question is find the mutual inductance. And I'll tell you a very simple task. The loop will generate a magnetic field here. There is a complex formula. Remember, mu naught I r square by r square plus x square raised to 3 by 2. X is known, r is known, current, assume it. Find the field here. The field will make an angle of 45 degrees with the area vector. So you find the flux, and eventually you will see the flux is something, 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 something into the current. Forget the current part. Whatever is remaining will become mutual inductance. So do it step by step. Chances of doing silly mistakes are really high in this question, like calculation mistakes, silly mistakes. So just do this. I have told you the procedure. Answer is there on the next slide. I will share you the solution and the answer key in the PDF form. Okay, the link will be made available after some time. Okay, so that was the last question, I believe. Yes, that's it. Thank you so much, guys. I hope you enjoyed today's session, and smash that like button and subscribe to the Vedantu JEE English channel. Okay, bye bye. Have a great time. And if you want more such sessions, please comment below, okay, for JEE Advanced specifically. Bye bye. Have a great time.